Hello, everyone. It is 1 o'clock, so I see a lot of people are still joining, but I want to get started so that we have enough time to go through this whole webinar and answer questions at the end. So thank you so much for joining me today for my webinar. We actually had a record number of people sign up for it, so I really appreciate everyone taking their time today to come on this journey with me. So for those of you who don't know me and haven't been to any of my previous webinars, my name is Amber Brown, and I'm the North American Sales Director for Move Solutions. And a little background on the company, Move Solutions. We design and manufacture structural health monitoring sensors. We were founded about 5 years ago in Italy, but because of all of the problems in the world with infrastructure, we have quickly grown globally. So I'm based out of Pittsburgh, Pennsylvania. We work all through Europe, the South Pacific, Africa, and North America, so United States and Canada. And why we have grown so rapidly is because we have a very focused approach on dynamic monitoring. So we have focused on the dynamic side of monitoring. And today I will be taking you through the webinar, Understanding the Causes of Structural Degradation, and to talk about the main causes and how you can use structural health monitoring to improve your infrastructure and combat the degradation of structures. I'm going to start by saying that we are very focused in this webinar on bridges. If I were to go over every application, we would probably be here for 3 hours, and I'm sure no one wants to spend that much time with me. So I'm very focused on bridges in this webinar, but just bear in mind that dynamic monitoring and our wireless sensors are really good for any type of civil infrastructure. So whether you're looking at rail monitoring, dam monitoring, buildings, culverts, the list goes on. So while we're speaking, just keep in mind, if you have a particular problem, most of our solutions can help your structure as well. So to get right into it, the main topics that we're going to be going over in this webinar and looking at the main causes and problems about structural degradation. The first one is aging. So as we know, we are in a time where materials and structures themselves have surpassed their intended lifespan. Everyday wear and tear has decreased predictions, and so we're at a very critical moment in time where we have many problems with infrastructure and the lifespan because we're at the end of it. So how can structural health monitoring help you to understand how to get the longest life out of your structure? We're also going to be going over climate change. I think we can all agree in this moment of time, we've had some pretty crazy weather over the past few years. We've had higher flood levels and more frequent flooding, higher scour rates, and more extreme temperatures, and it's predicted to stay on this trend for the future. Also, we'll be going over the external factors, so the heavy traffic leading to stress and overloads of the structures and phenomena that cause irreversible damage. As we know, there is a hurricane that hit Florida yesterday, and there was a hurricane that hit Canada. And we have all of these events that are happening and causing huge damages to the structures. So I want to go over how structural health monitoring can help contribute to the health and safety of the structure. And then finally, the maintenance plan. So right now, we have some very typical maintenance plans for structures and in particular bridges. And I want to really go over the processing of those maintenance plans and how adding in structural health monitoring can make a huge difference to the maintenance plans that either the DOTs have or the engineering firms are putting together, and how that can contribute to getting the longest life out of your structure. So first, getting into the life expectancy. So I found some statistics on the United States, but as we know, around the globe, we are reaching that end of life for a lot of structures and a lot of components that are used in the structures. So some Some statistics that I found are the average bridge age in the United States is 44 years old. And the average prediction for the lifespan is actually 50 years. So looking at that, it's a little scary that we are at this critical moment where all of these structures are needing maintenance, they're needing components replaced. And currently 42% of all the bridges are actually 50 years old. And 7.5 of those are in poor condition or structurally deficient. And I'm not saying that 7.5% of them are going to collapse immediately, but that means that 7.5% of them need something done to them. And trying to allocate those resources and coming up with maintenance plans is something that's really tricky and difficult for DOTs to do, for asset owners to do. So talking about the maintenance plan, so I really scoured the internet and looked at different maintenance plans from all over the United States. And I found many, many things in common. So this is just a very cut down version of what typically happens with bridges, in particular bridges. So I saw that, there's many trends, and now this is not cut and dry, it depends on state to state, DOT to DOT, but typically on average, bridges are inspected every 1 to 2 years. And once again, maybe some bridges are inspected every 6 months, depending on certain problems with them, or later. So it really depends, but on average, they're inspected every 1 to 2 years. And then after a problem has been identified, there is quite a lengthy process to go through to get the proper repairs and replacements needed. So if you are inspecting a bridge and you find a problem, there are various things you have to go through. So you're visiting a repository of information about the bridges, putting together a priority list and an inventory list, having a meeting or meetings regarding it and trying to allocate the resources, coming up with if it's a priority, if it's not a priority. And then you have all of the contracts and open bids and closing bids and all of those things that happen after a bridge is inspected and a problem is found. And once that problem is identified, depending on what the problem is, there are various actions that need to be taken to ensure the safety of that structure and ensure that it's not degrading further while we're going through all of this processing. And that could include decreasing the load size on the structure, closing the structure, short-term monitoring plans. And those are ensuring the safety, but also looking at that, you can see that it also has an impact on the community. If you're waiting for a lengthy process to make repairs and go through all of the processing, decreasing the load size could have a huge impact on, importation of goods. If they have to find an alternate route, it can also impact the structures around the structure. They're now taking alternate routes, maybe passing over smaller bridges in the area, and that's putting more stress on other bridges, which can ultimately affect the overall degradation of surrounding bridges as well. Not to mention the problems with emergency vehicles, with ambulances, with fire trucks that now have to find alternate routes. And closing structures, the same problem. You're rerouting the traffic and causing new traffic patterns, which can put more stress on other structures and also, greatly impact someone's morning commute or evening commute. But something that this plan that is currently happening with the inspections and kind of taking a reactive approach to finding problems with bridges is all of the in-between. So you're performing inspections, on a regular basis, but during the time that you're not performing the inspections, there's a huge unknown about the structure. And so I put together this scenario to kind of spell it out and show you the problems with the current plans and how structural health monitoring can greatly impact the safety and health of the structure. And okay, so for example, say you perform an inspection on January 1st, 2023, and you find no problems with the bridge and you visit that repository of information about bridges, and depending on the state that you're in or the previous bridge conditions, the next inspection is scheduled on January 1st, 2025. Now, in April 24th, 2023, there's forecasted rain for the next 10 days, which might sound crazy to some of you, depending on the area that you live, but being from Pittsburgh, it's something that I normally see is forecasted rain for many, many days, where we get flooding, the rivers are very high, ponds are flooded. And so during that time, there's an unidentified problem with the bridge that was never found with inspection. And so because of all this flooding, this bridge in particular had some bridge scour. But during the flooding and the increased velocity of the water, that bridge scour worsens and becomes critical. But there's no way of knowing that that condition has actually become critical and that the bridge is susceptible to collapsing. And so on June 1st, 2023, the right load hits at the wrong time and you have a structural failure. And as you guys know, we have been seeing more and more structural failures around the world. And by using a structural health monitoring system, you can look at the structure 24/7. You have endless amounts of data. You have alarms and thresholds to set to be alerted to changes in that structure. So if you were monitoring this bridge, you would have seen peaks in the data. You would have been alerted and emailed saying that there's a change in the condition to the bridge. At that moment, you can take the actions that you need to fix the bridge. And also, if you think about it, from the other side of things, not just safety, but fixing a bridge when you find the problem is much, much more cost effective than trying to rebuild a structure. That takes us into the next point, which is climate change and how climate change is affecting the degradation of our infrastructure. So as we know, globally, climate models predict continued warming in the future. And this factor, combined with the normal aging and the poor maintenance, makes bridges in particular, along with other assets, a highly critical asset to monitor. One of the problems with the climate change is the accelerated material degradation. The projected higher temperatures, increased precipitation, and relative humidity in some areas may all contribute to an increased risk of deterioration of bridges. Now, this can affect different components of the bridge, different materials like concrete, steel, and timber, and affect materials such as plastics and rubbers that are used in some of the components in the bridge. Also, the future climate will allow more favorable conditions for certain organisms that can attack certain components, such as wood. Also, with the increase in temperature and the heat waves can significantly impact rails. And I know we're seeing this all over the world where we have the railways buckling and moving from increased temperatures. And something that you have to think about is the impact that has on rail bridges. So if you're looking at a rail bridge and you have the rails buckling under the heat on the bridge itself, this can cause deformations in the rails, which actually alters the dynamic behaviors of the bridge as loads are passing over. So it's not just worrying about if the train is going to derail because of the deformed rails, but it's also worrying about a structural failure because you're changing that dynamic behavior on the bridge, and that's not how it was designed and built. Another component is the floods. So as we have increased temperature, the sea levels are rising, mainly from the higher temperatures and the accompanying thermal expansion of the ocean water. We also have increased precipitation, and that's contributing to more flooding. And there's many safety problems with flooding in bridges. You have a total risk of submersion. You have also a higher risk of bridge scour. So the structural health monitoring solution. So what can we actually do to help with the degradation of bridges and make the infrastructure a little safer and one of them in the life expectancies is boosting the lifetime and safety of the structure. So you're able to monitor in the short term and the long term, and you're boosting the safety, you're boosting the lifetime because you're able to take action much sooner. You're being proactive rather than reactive, and you're finding the problems much, much sooner and scheduling the maintenance when you know there's a problem instead of waiting, a year or two actually after the problem has came about. This is much more cost effective, and it also gives you continuous observation and data for new projects. So by monitoring the structures that you have, you're able to see how certain components, how the design of the bridge is holding up over time. And you're able to use that data to have better product development in the future. So instead of having, a 50-year lifespan prediction, you can use all of the data that you've been gathering to hopefully increase that. So you can change out some components, maybe change the design a bit, and have a better product development overall. The fundamental parameters that we monitor in this case would be the dynamic and static parameters. So the accelerations and the dynamic displacements of the bridge, the static parameters, so the inclinations and the static displacements, and also the modal parameters. So we're able to take those dynamic parameters and perform modal analysis, looking at the frequencies, shapes, and damping of the structure. And that's how you get that proactive response, because you're able to see slight changes in the structure long before you would see a static change. So before you see a movement on a total station, or before you would see a movement on a tilt meter, you're able to see those slight frequency changes. And then also it's very important to look at the environmental and geotechnical parameters as well. Understanding what's going on around the structure during certain seasons, during certain wind speeds, the air temperature, the humidity, the groundwater levels. You're able to take all of that data to understand if there are changes in the structure. You get a better understanding of why there are changes in the structure, and you can relate them to external events. So the structural health monitoring solutions in the maintenance plans is really improving the standard maintenance and inspection by condition-based monitoring. And that's giving you the opportunity to detect that damage in an early stage, enabling that proactive response and optimizing the maintenance process. You're able to see which structures are structurally safe and sound and which ones aren't. And you're able to prioritize your resources and put the resources where they need to go. There's two factors that we can do. So there's the short-term monitoring and the long-term monitoring of a structure, and they're both important when you're talking about maintenance plans. So the short-term is understanding the peak analysis, understanding if there is a change in the short term, and being alerted to that change so that you can take the proper action in the short term that you need to take. And there's also the long-term monitoring. So this is important with the life predictions of the structure, and also understanding that structure over time. So that's taking all of the dynamic analysis and understanding the trends over time, performing the modal analysis, understanding the displacement trends of the structure, and understanding over time if there are changes, if they're related to certain weather conditions, seasons. If there is a problem with the structure, you're able to see that over time. So I wanted to have a specific case to talk about today, and we picked bridge scour because I've had many, many meetings with DOTs, with engineering firms, and really globally, this is a huge problem, is the problem of bridge scour. So for those of you that don't know, bridge scour is the removal of sediments such as sand and gravel from around the piers or abutments of a bridge. And I'm specifically talking about hydrodynamic scour, and that's caused by fast flowing water that's carving out these scour holes. In the United States particularly, this is one of the three main causes of bridge failure, and it's something that's really, really difficult to monitor for. So if you look overhead, you can see an example of how when water is flooding, the velocity of the water increases. And as you can see around the abutments or piers, it's carving out particular holes. And when that erosion occurs, it's extremely dangerous for the structure. It's losing its integrity that is in the ground. And also a huge problem is that a lot of these old structures, you don't even know how deep those piers or abutments are, because you may not have plans on these old structures. And so you have to monitor it very, very closely, which takes a lot of time, a lot of manpower, a lot of physical inspections. So to talk about how we monitor for bridge scour, and it's something that is actually pretty different than how it's typically done. So right now, the most common monitoring for bridge scour that we come across is understanding the scour itself. So directly monitoring the scour around the abutments or piers. By doing that, you're understanding if the ground is eroding away, but there's also a huge problem with that, because commonly the scour holes are not visually what you expect them to be. So a good example is if you're walking along the beach at the edge of the water and you see your footprints, and the water comes and washes away your footprints. That happens the same with bridge scour. So when the velocity of the water is high and it's carving out these holes, you can visually see it. But when the water calms down, it typically will fill back in the holes. And the problem with that is that you're still losing the structural integrity around that pier or abutment, but you can't visually see, or whatever monitoring equipment that maybe you're taking measurements of the ground, it's saying that the ground has not moved, but actually it has, and it has just filled back up with more sediment. So how we monitor for this specific case is by dynamically monitoring the structure itself. So on the right-hand side, you can see this is how we would typically set up a bridge to monitor for bridge scour. On the top, you can see the span where we would monitor the dynamic and static behaviors, understanding the dynamic displacements, understanding the modal analysis using our accelerometers, and understanding the inclinations with our tiltmeters. At the bottom, you can see the piers into the ground. What we're doing here is we are monitoring those directly, dynamically and statically. And what you can do with that is understand if there are changes based on the dynamic behavior, because as the sediment is washing away and it's losing that structural integrity, the length of that pier is changing. And when the length of that pier is changing, you're going to see changes in the frequency of the structure. You can also use all of the geotechnical probes that you want to use. So whether you're measuring the water levels itself to keep up if it is flooding, and also directly monitoring the scour as well. But on top of that, you're doing a whole dynamic analysis and you're getting a better look of how the structure is behaving instead of just looking at the actual ground around the structure. So we are at 123. I want to quickly mention, so I think a lot of you are probably aware of the infrastructure bill in the United States. So this is in particular for the United States. Last week, I believe, or maybe the week before, they actually put out a smart transportation program. It's part of the infrastructure bill. And what that program is doing is investing in technology, and they name specifically sensors for infrastructure. And I read through the program, and they're actually looking for new technology that is well established, but not quite widespread. And they're giving you the opportunity, I believe they have around $160 million allocated annually for the next 5 years to invest in sensors for infrastructure and see the data that you're getting from them and see if it can have a benefit to the overall infrastructure of the United States. So I wanted to mention that because it's something that we fit perfectly into. And if you have a structure that you have been interested in monitoring, you think would greatly benefit from monitoring, we would be happy to put some monitoring plans together for you guys. That way you can submit them for this new program, which is the Smart Transportation Program. So we have 5 minutes left. If anyone has questions, I can answer any questions. So the question is, your bridge scour example provides information after the fact of scour occurring. Would you not want to know scour is occurring at a level where action can be taken before measurable distress to the structure has occurred? Yes, I mean, in an ideal situation, of course. This is more of a solution when you have scour critical bridges. I know that, for example, the Pennsylvania DOT has a number of scour critical bridges that every time it floods, they have to physically go out, inspect the bridges. So it's a good way to monitor when you know that there is a scour problem. Understanding it before would definitely be, the ideal situation. Do I have any other? Oh, here are some more questions. Okay, so what do you mean by static parameters? So static parameters are understanding if the structure is moving statically. So inclinations, a good example would be if you're measuring with a total station and you're taking direct measurements and you're seeing if the structure has moved statically. So if it has moved from point A to point B. So it's just a direct movement of the structure. The dynamic parameters are understanding the accelerations, the frequencies of the structure. So understanding the vibrations of the structure. How do you distinguish between traffic noise versus signals from degradation of the bridge? So we have various algorithms and tools that are embedded into our platform that helps distinguish between traffic noises, kind of like that white noise, versus the degradation of bridges. We use statistical analysis, look at them over time. You're also able to set the thresholds. So you can set some of the thresholds on certain sensors above the level of basically traffic noise. So anything after that is what you're going to be alerted to. Do we have any other questions? I don't think so. Thank you so much, guys. If you guys have any projects that you want to look at, or if you want to talk about any specific cases or scenarios regarding a monitoring project, please reach out to me, or you can, drop something on the website as well, and we would be happy to talk about your particular problem. Thank you so much, and I hope you guys have a great rest of your day. Will I email the presentation? Absolutely. We can email it, and we will also upload the recording from this as well. Thank you so much, guys.